Hello, my name is Keshwani. This is K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 171. Page 171, and today is our lesson number 151. Please turn to it. Problem number 138. Problem number 138 is what we're going to do. Problem number 138 is a very straightforward problem. They tell us that P over Q is less than 1. Now the only way the fraction can be less than 1, given the fact that both P and Q are positive integer. How do we know that? Because they tell us that. They tell us in the problem that they are both positive. Where is it? P and Q are both positive integers. So given the fact that they are both positive, if one of them was negative, of course, then of course it would be less than 1 because the fraction itself would be negative. But here what they're telling us is that the fraction is positive and yet less than 1. The only way a fraction can be positive and be less than 1 is if the top is less than the bottom. In other words, P over Q we are told is less than 1 if we multiply both sides by Q, and we can do that because we are told that Q is positive. Because Q is positive, we can multiply both sides of the inequality without having to worry about changing the direction of the inequality. And if we were to do that, Q drops out, and what we end up is that P is less than Q. Top is less than the bottom. So if that's true, then the only thing that must be true, the question is which of the following? The question is which of the following must be greater. The most important word here is must be greater. Out of the 5 answer choices, more than one answer choice you will find in a situation that it may be greater than 1 based on what you plug in for numbers. It may or may not be greater than 1, but there is only one answer choice that has to be greater, that must be greater. And that answer choice is this. If you reverse the thing, if P over Q is less than 1, then that implies that Q over P must be more than 1. That's what it is. Because the top is less than the bottom. So if you put the bigger number on the bottom, the top is less than the bottom. If you put the smaller number on the bottom and the larger number on the top, that's more than 1. That's it. We're making too much fuss about nothing. The answer is E. The answer is E. I think I explained way too much for something simple as that. That's all. For example, 3 over 5 is less than 1. If you were to plug in 3 for P and 5 for Q, of course 3 over 5 is less than 1. That implies that 5 over 3 must be more than 1. That's all it is. That's all. Which is what your Q over P is. Let's do the next one, shall we? Enough of this. Sometimes if the problem is too simple and you try to explain it, it doesn't actually get anywhere. It's just we keep going in circles. Problem 139. Here we are told that A takes 4 hours to do a job. We are told that B takes 3 hours to do the same job. The question simply is, how long will it take for them to finish the job? How long will it take for them to finish the job working together? If they're working together simultaneously at their respective pace, how long will it take? Now listen, in order for you to understand what I'm about to do here, or what I would like you to do here, I'm going to make a note here. I wrote down somewhere here, right here. I would like you to compare this problem with with number 103 on page 166, which was covered on day number 107. Now here's what's going on. There are two ways you can go about solving these kind of problems. These are called work problems. They appear all the time in the exam. And there are two ways you can go about tackling them. One is the classical way, the traditional way, the orthodox way, the classical way, the conventional way, which is with the algebra. And the other one is just a quick and dirty way, which is by simple logical thinking, you can eliminate a lot of the answer choices. For example, here we have two machines. We have two guys, two machines, two people, doesn't really matter. A, we are told, takes 4 hours. So if both were to work as slow as the slow machine, if both were to work as slow as the slow machine, as the slow one, I'm not even sure if it's a machine or a person, whatever that is, it doesn't matter. Yes, if both were to work as slow as the slow one, it should take how long? The slow machine takes, listen carefully, the slow machine takes 4 hours. If you were to put two slow machines together to do the job, since one slow machine can do the job in 4 hours, two of them working together should be able to finish the job in 2 hours. Similarly, if both, this is hypothetical statements, these are hypothetical statements obviously, if both were to work as fast as the fast one, it should take how long? The fast machine can do the job in 3 hours. So if you were to put two fast machines together to do the job, they should be able to do it in an hour and a half the amount of time if you put two of them together. Hour and a half. Now this is the first thing I like to do. This is the very first thing I like to do before I decide to waste my time trying to actually work it out, because in a lot of the cases we can knock out a lot of the answer choices, and then if the work needs to, if you still need to do some more work, we'll do some more work. Let's see what we can knock out here. Let's see what we can knock out here. So what we find here is that, what we find out from here is that what this implies is that the correct answer, whatever it is, has to be between 1.5 and 2. It has to be between 1.5 and 2. It cannot be exactly 1.5. It cannot be 1.5 because both machines are not working as fast as the fast one, and it's not going to be 2 hours. It cannot be 2 hours exactly because both machines are not working as slow as the slow machine is. One is faster than the other, or one is slower than the other, however you want to look at it. So it's got to be somewhere between 1.5 and 2. Any answer choice that falls outside this range is utter nonsense. Let's see what we can do here. The answer choices are 7 and 12. That's only half. 1.5. That's not going to work. So E says 7. That's not going to work. D says 3.5. That's nonsense. That's it. That's your answer. Whatever the hell that is. Whatever that is. We're not going to worry about it. That's your answer. That's it. And that's all. We are done. You understand? Now, if you insist that I do it in a proper way and that I'm cheating and you don't like it, we're going to do it the proper way. Okay? So for that I need the room. Let's do it here the proper way if you insist. The proper way to do without having to do even the so-called proper way, I'm not going to do it the exact proper way, the puritanical way, because I'm not interested in that. Here's my proper way. The proper way here would be, ask yourself, what is that? What can you think? Can you think of one number that you can divide both by 3 and 4? Can you think of a smallest number that will be divisible by both 4 and 3? Start with that number. That's 12. That's 12. How many jobs can A do in 12 hours? A can do because A takes 4 hours to do the job, because A takes 4 hours to do the job, A can do 3 jobs. 3 jobs in 12 hours. Similarly, B can do 4 jobs in 12 hours. Because we are told that B takes 3 hours. If B takes 3 hours in 12 hours, they should be able to do 4 times the amount of work. Therefore, A and B together can do 3 jobs and 4 jobs, that's 7 jobs in 12 hours. If they can do 7 jobs in 12 hours, they should be able to do 1 job in 12/7 of an hour. That's it. That's all it is. Just out of curiosity here, let's turn to page number 166, number 103. We're going to redo it. 103, 166. Let's turn to it, please. 166, 103. I'm curious. Okay, let's do that number 103. If we're done with this one, I'm going to erase all of it. So we're doing number 103 on page 166 now. Okay, so ignore that part right now. It says the water from one outlet flowing at a constant rate fills the swimming pool in 9 hours. All right, so the one is 9 hours for one, and the other one is 5 hours. It's 5 hours for the other. In other words, one can do the job in 9 hours, the other one can do the job in 5 hours. The question simply is, if they were both work together, how long will it take to finish the job for them to do, if they were going to work together? Well, that's very simple. Here our range is half of that amount, which is 4.5. Why half of that amount? Because that assumes, you ask yourself, if one can do the job in 9 hours, how long, if the fast one is this guy, he can do it in 5 hours. If the fast one were to work as slow as the slow one does, if the fast one were to work as slow as the slow one, and if the slow one takes 9 hours to do the job, 2 slow machines together should do it in 4.5 hours. Similarly, if the slow one were to work as fast as the fast one, which can do the job in 5 hours, if the slow one were to work as fast as the fast one, and if the fast one can do the job in 5 hours, 2 fast machines put together can do it in 2.5 hours. That's it, that's your range. Any answer choice that falls outside the range is utter garbage, pure nonsense. Let's see what it can do here. A, B, C, D, E. A says 0.22. That's nonsense, 0.22. That's insane. 0.31. No, we're looking for something between 2.5 and 4.5. E says 4.56. I don't know where the hell they come up with these numbers. 3.21. 3.21. There you go. There is your answer. That's it. That's your answer. C. Whatever the hell that is. But C says 2.5. It cannot be exactly 2.5. Did I misread it? 5 hours and 9 hours. So that's 4.5 and 2.5. 103. The answer choice for 103 is D. Oh, I was going too fast. I was being too hasty, wasn't I? It cannot be exactly 2.5. It has to be between 2.5 and 4.5. It cannot be exactly 2.5. Exactly 2.5 would have meant that both machines are in fact working as fast as the fast one, which of course is not the case, which is not the reality. I was being too hasty, I was being too cocky, I was not paying attention. 3.21 falls in this range. C is exactly 2.5, that cannot be right answer. As soon as I was left with C, as soon as I was left with only answer choice C, I realized that something has gone awry, something has gone cuckoo, something has gone, I've made a boo-boo here, because the answer cannot be exactly 2.5, answer cannot be exactly 4.5, it has to be something in between. And in my haste, I was being cocky, as I said, in my arrogance, I was being too ostentatious to show off. I crossed out D in a hurry without actually paying attention to the fact that 3.21 does in fact fall between 2.5 and 4.5. But you see how weird that number is, 3.21. It's a weird number, and yet we are able to tell that that's the answer because that's the only one that makes sense. It has to fall, the amount of work that they're taking has to be somewhere between the amount of time it will take if you were to put two fast machines together and the amount of time it will take if you were to put two slow machines together. It has to be the case. Do you understand? I'll see you tomorrow, okay? Bye now.